Imagine a company that manages something like $2.4 billion in on-chain assets.
Right.
And they run these massive marketing campaigns. They actively audit their own smart contracts for vulnerabilities. And, they resolve complex treasury issues in basically milliseconds.
All of that, yeah.
All of that. But here's the kicker. They do all of it without a single human employee.
None, which is just, it completely shatters our traditional understanding of what the future of work looks like.
Totally.
We aren't looking at sleeker apps here or, friendly AI assistants that just help you draft a better email.
Yeah, we're way past that.
Way past.
Yeah.
We're looking at this profound structural shift where software transitions from just being a tool we use to an entirely autonomous workforce.
And welcome to the deep dive. Our mission today is to unpack this really wild stack of sources you sent over. We've got highly technical architectural blueprints, UI design specs, and even the training manual for an agent sim game.
Yeah, the game manual is fascinating.
It is. And alongside that, these incredibly striking, almost cyberpunk-styled manifestos detailing what they call the rise of the machine economy. And, to set the stage for you, the listener, there's this one visual from the source materials that just grabbed me right away.
The ostrich.
Yes, the ostrich. It's this stark image of an ostrich literally burying its head in the sand. And the text next to it argues that this represents traditional tech workers and businesses who are just in total denial about what the sources call Darwinian capitalism.
Right, because the core argument they're making is that the next cycle of Web3 won't be won by speculation or, token hype or meme coins.
Right.
It's going to be won entirely by autonomous infrastructure, which is exactly why understanding these blueprints is so critical for you.
Oh, exactly.
Because if you're trying to map where the digital economy is actually moving, it's not heading towards better user interfaces for humans.
Yeah.
We are transitioning from a speculative web where, people trade tokens based on narratives to a completely self-operating web.
A web that works in the background.
Yes. We're talking about invisible infrastructure. Algorithms that execute real-world outcomes at API speed with no human in the loop.
Okay, let's unpack this. Because the sources say that to really wrap our heads around this monumental jump, we have to look at the fatal flaw of our current digital economy. And surprisingly, that flaw is us.
As human beings.
Right. The entire ecosystem we use right now is designed for humans. We approve the transactions, we manually reconcile the databases, we sit around in Slack channels waiting for legal to sign off on a spreadsheet.
And the terminology the manifestos use for that specific bottleneck is human latency.
Human latency.
Yeah. In a digital ecosystem, every single time a process requires manual human coordination, you introduce friction. And friction in a financial system is literally just economic leakage.
So I was trying to visualize this while reading through the specs and think of the traditional corporate workflow like a relay race, but the runners just keep dropping the baton.
Right.
Every time a human has to sign off on an email or check a spreadsheet, the baton drops. That delay, that human latency, is what the system is constantly bleeding out.
Yeah, that analogy captures the systemic bleed perfectly. Because it leads directly to one of the boldest claims in the entire stack of documents, which is, if a system still requires trust, it is already outdated.
Wow. Wait, say that again?
If a system still requires trust, it is already outdated. The objective here isn't just to make, better AI chatbots, it's to create coordinated intelligence.
Okay.
So we are moving away from passive platforms where you log in to do work toward protocols that act. They act autonomously to eliminate manual administrative agencies and all that SaaS tool overhead entirely.
Because if you're stuck doing manual coordination at work right now, these sources basically view your daily workflow as a design flaw waiting to be removed.
Exactly. Value is flowing away from applications designed to capture human attention, and it's flowing towards systems that optimize for direct, verifiable outcomes.
But okay, having a team of genius AI agents is pretty much useless if the network they operate on is too slow, right? Or too expensive. If an AI decides to execute a split-second arbitrage trade, it can't just sit around waiting 10 minutes for the Ethereum network to process it while paying like a $50 gas fee.
Oh, absolutely not.
Yeah.
Which forces us to look at the underlying rails making all this possible. To build a hyper-efficient machine economy, a single blockchain architecture just isn't robust enough.
No.
So the sources introduced this cross-chain control plane built on 3 specific networks. They call it the Trinity of DLT, or distributed ledger technology, which powers the Denarii DFi Orchestrator.
Right, the Trinity. I really want to break this down because each ledger does a very specific job in this setup. First, you have the XRP Ledger, or XRPL. And the specs highlight this for handling really high-speed value transfer. We're talking sub-second settlement.
Yeah.
Plus, it provides native decentralized exchange liquidity.
Exactly. It acts as the high-speed highway for rapid capital movement.
Right. And then second, you have Algorand. The blueprints highlight Algorand for mathematical transaction finality and zero fork risk. And they actually list the native asset transfer mechanism using this specific Denarii asset, which is ASAID 897649551.
Which is such a specific detail.
It is. It really shows you how close this is to live deployment rather than just being some theoretical white paper.
But wait, I have to push back here for a second because I'm genuinely stuck on Algorand's role.
Okay.
If XRP handles the high-speed movement, why do we need mathematical finality? Like, what does zero fork risk actually mean for an AI?
Well, think about how a machine processes logic versus how a human does.
Right.
A human can handle operational ambiguity.
Sure.
If a blockchain network temporarily forks and a transaction gets rolled back or it fails, a human trader just, sighs, recalculates their gas limit and submits it again.
Right. It's annoying, but you deal with it. Exactly. But a machine cannot handle that uncertainty. It requires absolute mathematical certainty finality that a micropayment has permanently settled before it executes the very next sequential step in its code.
Oh, I see.
So Algorand provides that unhackable definitive settlement layer so the AI can proceed without checking over its shoulder.
Got it. That makes perfect sense. And then the third pillar of this trinity is Hedera Hashgraph, or HBAR. And this one is used for high-throughput consensus and logging these immutable audit trails for every single decision an agent makes.
Yes.
So putting it all together, I kind of like to think of this trinity like a high-speed automated transit system. The XRP Ledger is a bullet train moving the cargo instantly.
Perfect analogy.
Yeah, and then Algorand is the unhackable tracking system guaranteeing exactly where the cargo is at all times, making sure delivery can never be reversed. And Hedera is the tamper-proof security camera system auditing every single stock along the way.
That perfectly illustrates how the orchestrator exploits the complementary strengths of each network simultaneously. It's brilliant.
It really is.
Because by unifying these three chains into a single posture, they neutralize the traditional entry barriers of Web3, things like exorbitant gas fees and fragmented liquidity pools.
Right, all the stuff that slows us down.
Exactly. When you let agents execute cross-chain operations seamlessly, the system captures the ultimate competitive advantage, which is just pure execution speed.
Okay, so we've got the high-speed transit rails. Now let's meet the digital workforce actually driving these trains.
The fun part.
Yeah. This is the Paperclip AI Orchestrator. And this is where the blueprints get, frankly, incredibly wild. They describe it as a stateful coordination layer where you, the user, don't just chat with an AI, you deploy an entire matrix of specialized AI workers.
Full corporate roster.
Literally.
Yeah.
CEO agents, engineer agents, quant agents, social agents. You are modeling a completely autonomous business.
Yeah, it is a runtime capable of managing highly complex cognitive workflows across multiple corporate domains, and doing it without a shred of human intervention.
And the cost savings they detail are staggering. They break this down into 5 pillars of enterprise automation, covering over 100 specific utility tasks. Under Pillar 1, social automation, we aren't just talking about an app scheduling your tweets.
No, these agents are context-aware.
Right. They are actively scraping platforms, executing dynamic PR and viral campaigns, and resolving customer support tickets on their own. They're saving up to like $8,120 a month by completely replacing platforms like HubSpot.
It's massive. But then Pillar 2, which focuses on audits, is arguably even more critical. Because in a machine-native economy, a software bug isn't just a minor annoyance that you patch next Tuesday.
No, it's a disaster.
It is a direct financial liability. It's basically a vault door left wide open.
Seriously. The blueprints mention engineer agents continuously checking smart contracts for vulnerabilities like reentrancy vectors. And, for anyone not deep in the coding weeds, a reentrancy attack is basically when a malicious contract tricks your code into letting it withdraw funds over and over again.
Right, before the system even has time to update its balance.
Exactly. So having an AI constantly auditing for those specific exploits replaces external security consulting firms. That saves anywhere from $10,000 to $50,000 per audit.
Which is incredible.
Yeah.
And furthermore, Pillar 3 handles treasury monitoring with that same exact continuous vigilance. Premium analytics platforms traditionally rely on human traders interpreting dashboards, right?
Right.
But here, the agents monitor total value locked and Oracle Pig drifts directly.
Let's pause on Oracle peg drifts for a second. That's when the price of an asset on the blockchain suddenly disconnects from its actual real-world value, correct?
Correct. So if a stablecoin is supposed to be pegged to $1, but a sudden market panic pushes it down to, say, 98 cents on a decentralized exchange.
A human trader might take several minutes to even notice that.
Exactly. But the AI catches that drift instantly and executes an arbitrage trade to fix the discrepancy. It captures the profit in milliseconds, replacing tools like Nansen and saving another $5,250 a month.
Wow. But okay, Pillar 4 is the one that really blew my mind, the Agent Council.
Oh, this is fast.
Because instead of relying on one AI that might hallucinate a terrible answer, it's a collaborative jury of different AI models debating strategy.
Yes, the structured debate format is so clever. Routing complex queries through a multi-model jury provides this balanced, multi-perspective guidance. So one agent proposes a tokenomics strategy, and then a devil's advocate agent actively tries to tear that strategy apart.
While a compliance agent checks the legalities of the whole debate.
Exactly. It mimics the dynamic of a corporate boardroom perfectly. It entirely replaces human management consultants and saves upwards of $50,000 a year.
Add in Pillar 5, orchestration, which handles auto-generating sprint tickets and mapping dependencies, basically saving over 100 grand a year by replacing JRA, and you have an absolute powerhouse.
Really?
And the live telemetry data proves this isn't just science fiction. The sources show over 128,000 active agents currently deployed.
Yeah, that number is wild.
Those agents have executed 9.8 million tasks, processing over $2.47 billion in on-chain value, and they've done it with 100% uptime.
Managing $2.47 billion via software that literally never sleeps is just an incredible feat of engineering.
Here's where it gets really interesting, though, because to pull all of that off, the developers had to solve this massive technical hurdle, which the documents call the memento man problem.
Right, the statelessness flaw.
Yes, because standard large language model APIs, the AI we are all used to talking to, are fundamentally stateless, meaning every time you ping them, it's a fresh instance. They wake up with all their intelligence, but absolutely zero memory of what they just did 5 seconds ago.
And obviously, you cannot run a multi-billion-dollar corporate treasury with a CEO who has severe short-term memory loss.
Right.
If the CEO agent forgets the company's overarching strategy between API calls, the entire autonomous structure just collapses into chaos.
So how does the paperclip orchestrator solve this?
It implements two crucial mechanisms. First is what they call the heartbeat check-in system.
I love this concept. It basically forces the agent to read its goals before it's allowed to act.
Exactly. It functions as a mandatory, recurring validation loop. Before executing any task, the agent must read its designated persona, review the organizational goals, and explicitly define what success looks like for the current assignment.
It physically cannot interact with the blockchain without reorienting itself to the mission first.
Right. And then the second mechanism is the PRA memory system, which stands for Projects, Areas, Resources, Archives.
Because trying to cram a year's worth of corporate history into the AI's active context window would just dilute everything and cost an absolute fortune in compute power.
Exactly. So instead, it uses a file-based system. It's like giving the AI a digital filing cabinet. It can open the specific drawer it needs, read the strategic file for context, and put it back.
It's so efficient.
It really is. Maintaining that long-term context efficiently is vital. But this brings us to an incredibly important mathematical model detailed in the sources, known as the measurability gap.
Okay, yes, let's talk about the math here.
This model outlines a really stark reality of automation. We are looking at two diverging curves. On one hand, the cost to automate cognitive tasks is decaying exponentially. I mean, it's cheaper than ever to have an AI generate complex code.
Right.
On the other hand, the cost for a human to verify that work remains incredibly high, because human attention is biologically bottlenecked.
So it's incredibly cheap to generate actions, but incredibly expensive and slow for us to check if those actions are actually correct.
Exactly. That widening space between the two curves is the measurability gap. And when generation is cheap and verification is expensive, there's this massive economic temptation to just let the machines run unverified to save time.
Which sounds incredibly dangerous.
It is. The sources warn this leads to a hollow economy, filled with compounding, undetected machine errors.
And they actually mapped out the exact math of this failure in the documents. It's fascinating. If you have an agent with a 95% accuracy rate, that sounds fantastic on paper.
Sure does.
But if that agent runs an unverified 10-step sequence, that error rate compounds drastically. Let's say an agent misreads a decimal point on step 1. By step 10, the mistake has totally spiraled. A 95% accuracy over 10 steps yields a compounding success rate of only 59.8%.
Which is basically flipping a coin on whether your autonomous company succeeds or completely drains your treasury.
Right. So how do you fix that? How do you mathematically stabilize the system without reintroducing that human latency we talked about earlier?
Their solution is deploying an independent quality assurance, or QA, agent. This is a specialized agent strictly tasked with auditing the work of the executing agents at specific checkpoints.
So you fix the AI's mistakes by hiring an AI auditor.
Exactly. And by introducing this automated check and balance, they mathematically reset the error probability down to an undetectable 0.25%.
Wow. Literal agents managing agents. But I mean, you can't just unleash people to build these high-stakes swarms without serious training first. And that brings us to the agent sim game.
Ah, yes, the training module.
It's a full training module built right into the Denarii Orchestrator. It's called the Machine Economy Simulator.
Because the machine economy is deeply complex, and this simulation visualizes it all through what they call a holographic physics graph. Users can actually watch virtual capital stream between different agent nodes in real time.
Yeah, you literally see the capital flow from like a strategic liquidity director to a cross-chain security auditor. It really teaches you that these aren't isolated chatbots, they are interconnected nodes.
Right. If one agent drops the ball, it impacts the global treasury.
And your overall trust index. But my absolute favorite detail from this entire deep dive is the LLM Dungeon Master.
The synthetic crisis injection engine, it's brilliant.
It is so cool. The simulator uses an adversarial AI to actively try and destroy your company while you're learning. The Dungeon Master injects custom threat vectors like a flash loan liquidity drain.
And for anyone unfamiliar, a flash loan drain is an artificial market panic where millions of virtual dollars are borrowed and dumped instantly to break your token's peg.
Yeah, so your screen suddenly starts flashing red, your treasury balances start bleeding out in real time, and you have to scramble. You have to use the AI mitigation planner to generate an emergency patch and recover your trust index.
It really forces developers to think critically about edge case vulnerabilities before they ever deploy code that handles live mainnet funds.
Right, it trains incident response in a completely risk-free sandbox environment.
But if we connect this to the bigger picture, the real-world environment is definitely not a sandbox.
No, not at all.
When you move out of the simulation and into actual deployment, the security has to be ironclad. So the blueprints describe the absolute core of the system as the vault.
The vault, because these agents hold the cryptographic keys to real capital, right? So the user interface itself becomes a massive attack vector.
Exactly. Which is why the vault is designed with quantum security enclave shields.
So just to clarify the mechanics there for a second, that means the cryptographic keys are isolated at the hardware level, right? So even if a bad actor completely compromises that neon-lit dashboard, they literally cannot extract the private keys.
Correct. The keys remain permanently locked inside the enclave. And to authorize massive state changes or move core capital, the system relies on biometric blockchain scanners.
So you still have to physically, biometrically authorize those massive moves.
Right. Human-in-the-loop authorization, cryptographically verified. The attacker can't do it without your literal fingerprint or biometric signature.
But maybe the most fascinating security measure detailed here isn't even the cryptography, it's the economic gatekeeping. Because access to this incredible orchestrator is not free.
No, it's not freely given to anyone who just wants to spin up an agent. To prevent Sybil attacks, which is where a malicious user creates thousands of fake accounts to overwhelm the network, the system relies on a strict token gating mechanism.
The 2% rule.
The 2% rule. To enter the paperclip AI orchestrator, a user must mathematically prove they hold at least 2% of the total supply of the native DFI token in their wallet.
That is a massive paradigm shift. It completely transforms the token from just a speculative asset that you buy and hold on an exchange into a literal mathematical key required to access the autonomous infrastructure.
Exactly. If you don't hold the required stake in the network, you simply do not get the workforce. It mathematically ensures that the next generation of protocols is utilized exclusively by committed operators.
Filtering out the transient speculators entirely.
Precisely.
So what does this all mean for you as the listener? We've covered incredible ground today, moving from the macro philosophy of Darwinian capitalism to the micro execution of cross-chain AI agents.
And we are witnessing a definitive shift.
We are moving away from an era where humans manually push buttons in a user interface, trying to duct tape endless sauce tools together.
We are transitioning to a world of profound background orchestration. Algorithms are autonomously managing multi-chain treasuries, executing high-speed arbitrage, and running complex marketing campaigns, all visualized in these neon-lit cyberpunk-style dashboards.
But it's vital to remember the core principle running through all these sources. The machine economy isn't about entirely replacing human beings.
No, the documents are very clear on this point.
Yeah.
The goal is removing friction. Humans remain responsible for the values, the vision, the ethics, and the overarching governance of the system.
The machines just handle the execution.
Exactly. You provide the strategic intent, the orchestrator delivers the outcome.
It frees us from the latency of administration.
Right.
Which leaves us with a final thought to mull over as we wrap up today's deep dive.
Right.
If coordination, not information, but seamless, instantaneous coordination is the new currency of the digital world, what happens to traditional businesses?
Yeah, what happens to the company that relies on endless meetings, manual email chains, and a workforce that clocks out at 5 p.m.?
Exactly. What happens when their newest competitor is an entirely autonomous, self-healing swarm of agents that literally never sleeps?
It's the ostrich burying its head in the sand. The autonomous world won't wait for permission.
Don't be the ostrich. Thanks for joining us on this deep dive into the source material. We'll catch you next time.